Okay, so the last day we went through measures of average. Okay, so we had the mean, mode, median. And as we could see, the only thing that really affected which one we chose, the optimal one, was whether it was an outlier or not, or if it was categorical. Okay, so today we're going to do measures of variability. So what this actually means is it's about how spread out the data is. Okay, so um, you might come home to your parents after the Christmas exam and they'll go to you. Generally, they'll say, "How'd you get on?" You'll say 56%, or you might say 42%. Okay, and they'll go, "What was the average in the class?" And you might go 53, but that might have had three people get 100%, and when the median actually probably would have been closer to what you got. Um, the range and interquartile range. The range basically tells you the difference between the top value and the bottom value. Okay, so if I'm looking to put classes together in the school here, and we're talking about quality of the class. Well, the first thing I might say is that, oh, here's the average of the class. And then the next thing someone's going to say, well, what's the difference in ability in the class? Well, I say the top person's 100%, the bottom person is 4%. That's a 96%. But the other class mightn't have the same, might have the same average as us. But what they have different is they might have everybody in the class between 40 and 60. So it's way more condensed. Okay, so the range is the very first one. So in a class, the range is the top minus the bottom. That's for anything. Okay, tallest person in the class is Big Paulie, 194 centimeters. Smallest person in the class is Louis Lovett, 150. That's 44 centimeters. Okay, so that's the range. Yep. Now, you got to take into consideration the range might be in that class. You might actually have Paul's 194 and Louis 150, but everybody else in the class might be between 170 or 175 and 162. So they actually are a good bit outside. So they're not going to represent this data, and we always have to go back to the word represent. Okay, so we use range ideally when there's no outliers. Okay, hopefully that makes sense. Now the next one is quartiles. So interquartile range. Interquartile range, I'm sure you're already thinking this right now, is when optimally, it doesn't mean that they can't ask you if they're, like in the first one, they can still ask you the range if there is outliers, but if they ask you in the exam, which one would you advise? If there was an outlier, you say interquartile range. If there is an outlier. Okay? So interquartile range, there's four quartiles. It's basically saying the first quarter, the second quarter, third quarter, fourth quarter. Okay? Really simple. Okay. So with median, what we had was a half n plus 1. Okay? And we'd find out what the data was for that. That is the second quarter. It's the halfway point. So it is the median. Okay? Next one is if I had the first quarter, obviously it's a quarter, n plus 1. Third quarter, 3 quarters, n plus 1. Okay? And obviously the last quartile is the last number. We forget that. Okay? We never use that. So that's the end. Okay, so let's say I put up a bit of data here. We order it. Now you would always have to order it. This won't come ordered like this. Okay, maths test results. So 92 is our outlier. So we optimally use interquartile range. Now, n represents the number that it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So a quarter of 14 plus 1, well, that is a quarter of 15. So that gives us 3.75, which means we get the fourth and the third. I'm not sure why I did it in reverse order. Okay, so 1, 2, 3, and that's the fourth. So therefore Q1, I should give myself a bit more space, is 2 plus 3 over 2. So it's 2.5. Circle it. This first part helps us get to this. So why is it? That's the third and that's the fourth. This one, it's a half. I've already worked out what n plus 1 is. It's 15. That's 7.5. So it's the 7th and the 8. So Q2 is 1, 2, 3, 4, 5, 6, 7. That's 6 plus 7 over 2. 6.5. Okay, and then Q3, 3 quarters of the previous one. Well, if this is 1 quarter, 3 quarters is going to be 3 times it, isn't it? So 14 plus 1, that's going to be 7.5. Yes. Sorry, no. Why am I doing? Working that out. That's 3.75. 3.75. That's going to be 11.25. Sorry, my maths is bad. 3 quarters of 14 plus 1 is that. So therefore, I'm going for the 11th and the 12th. Q3 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12th. So 11 plus 12 over 2. That is 11.5. That's Q3. Okay, quartile Q1, Q2, Q3. That's the quartiles. Now the thing that we're looking for is called interquartile range. This, I should have said at the very beginning, this is 10.5. So page 386 in your book. Okay. Interquartile range is Q3 minus Q1. Yeah, it's basically taking out the extreme values. And Q3 is 11.5. Q1 is 2.5. The interquartile range is 8. Okay, basically all that's saying is that the range taking out the outliers is 8. Yeah. There's nothing else to this really. This is pretty simple. Yeah, that's the very first thing. Now the second thing that you've got is standard deviation of a frequency distribution. That's on page 388. So standard deviation. Standard deviation is another measure of spread. Yeah, it's just saying what the general, how much it deviates in each from the average. It's just another measure. You don't have to. They'll only ask you which one would you use, range or interquartile range, if there's an outlier or not. Standard deviation really just comes into when you're doing stats. It's really important for that. Now, if you look at page 388, they give you the formula for this. And they actually make it pretty straightforward for you. So the example that they give, it's 6, 9, 10, 12 and 13. They want to get the standard deviation of that. Okay, in order to get the standard deviation, we need to know what the mean is. So the mean, the X with the hat on it means it's the mean of the sample. Okay, mean of the sample. Add them all up. 6 plus 9 plus 10 plus 12 plus 13 all over 1, 2, 3, 4, 5 and the mean is 10. Okay, easy enough. Now, the formula for standard deviation. Standard deviation is kind of like an O and an OR thrown into one. I'll explain these symbols. Sigma. Sigma means the sum of x minus x squared all over n. Okay? So all that means is as follows. Sigma x is 6 minus 10 squared plus the sum of, next one, 9 minus 10 squared. Next one, 10 minus 10 squared, running out of space, 12 minus 10 squared plus 13 minus 10 squared all over 5. Why 5? Because that's n, the number there. If I was to put all of that into my calculator, it will come out square root 6. Standard deviation is 2.45. Basically, the standard deviation is just telling us the difference from the mean. Yeah, so it's the range from the mean. It's not giving us the actual range or anything like that. So you don't really need to understand standard deviation, you just need to be able to apply it. Right, the only other thing that you need to know here is your standard, well, we'll leave it at that for today. Actually, we'll leave it at that there, and that's going to be part 1 of your homework. Your homework that I want you to do is very simple. You're going to go to page 392, and I want you to do question 1 all the way through to question 8. Okay? Okay, good work, and I'll upload another video for you tomorrow.